this is the method of substitution. So it says isolate a variable from one of the equations, substitute its equivalent expression into the other two equations for that same variable. So that's exactly what we did. I chose to isolate y so that I could plug it in to both of these other two equations for y, so that it would match exactly these instructions. However, we can actually do it a little bit differently. Instead of isolating y and plugging it into both of those, what we can do is isolate x if we isolate x, we're going to have x minus y plus 4z equals 10. If we isolate x, what two variables will we have left? Y and z. What do you notice here? That one's already down to y and z. So we'll only have to substitute it into one of the other equations as opposed to two. Does that make sense? Okay. Questions? I heard what?
Why do we only have to do one substitution? Like what change?
I'm isolating x. So here's the example from last period. I isolated y, and I plugged it into both of these other two equations because there's a y in both of those equations. What we're going to do is we're going to isolate x, and then we would plug it into both of the other equations. There's an x here. Is there an x here? So we won't have to plug it into that other one. So how do I isolate x here? Add y to both sides and subtract 4z from both sides. And that gives us x equals y minus 4z plus 10. Thank you. So now we're going to take this expression that is equivalent to x, and we're going to plug it into the other two equations for x. Oops, not the other two equations, just this one. Because this equation up here doesn't have an x to plug into. So we're going to have 2 times x, which is the expression y minus 4z plus 10, plus 2y minus z equals 12. Now let's simplify. So we're going to distribute this 2 to all three terms. What do we get when we distribute the 2? 2y minus 8z plus 20 plus 2y minus z equals 12. And now we're going to clean that up. We're going to combine like terms. We have 2y and 2y. What does that give us? We have negative 8z and negative z. What does that give us? Negative 9z. And then is there anything to combine with the 20? Nope. So we just put plus 20 equals 12. And now if I want all the constants to be on the right side of the equation, what do I do?
Subtract 20.
Subtract 20 from both sides. What does that leave me? 4y minus 9z equals what? Negative 8. Now, we can take this equation and this equation because they have the same two variables, and we can use those as our subsystem to solve for y and z. could use substitution or elimination at this point, but since we would have to multiply both equations in order to use elimination, I think we should use substitution. And I think that we should isolate y instead of z. Can you tell me why? Can you explain why we would want to do that? Isolate y instead of z? Not just a positive. If we're isolating z, what are we going to end up dividing by? 6. What's 3 divided by 6? Either a decimal or a fraction. If we divide by 3 at the end, we'll end up with whole numbers. So that's why I think we should isolate the y here. So we're going to have 3y, is that a minus or a plus? Minus 6z equals negative 6. If I'm isolating y, what do I do here? Add 6z to both sides, leaving me with 3y equals 6z plus 6. What do I do next? Divide by 3 on both sides. That means we're going to divide every single term, all the terms, by 3. This one?
6z minus 6.
Oh, thank you. Here, let me fix that. Oh, there we go. Minus 6, thank you. So we're going to divide by 3 now. And what will that give us? Y equals 2z minus 2. So what do we do with that? Substitute it in. We're going to take this expression that represents y, substitute it into the other equation for y. So we'll have 4 times y, which is 2z minus 2, minus 9z equals negative 8. And we'll simplify. What do we get? 8z minus 8 minus 9z equals negative 8. What's 8z minus 9z? Negative z. What do I do next? So we get negative z equals 0. At this point, I would technically divide by negative 1. 0 divided by negative 1 is 0. So I've gotten one of my values to the 3 variables we're solving for. What do I do at this point?
You can substitute this value.
So I'm going to substitute this value back into one of the 2 equations that we had in the subset, okay? I'm going to put it back into one of those. Which one do you recommend? The first one? Okay, so the 3y minus 6z equals negative 6. And we're taking that z and plugging it in. So we're going to have what is 3y minus 6 times 0? What is that going to simplify to? 3y equals negative 6. And then divide both sides by 3. And what does that give us? Y equals negative 2. Now we have 2 of the values that we were solving for. We just need the third one. Which one is that? X. So we're going to take y and z and plug it in to either this equation or this equation. I'm thinking this one. Why?
You wouldn't have to distribute.
Yeah, no distribution, no division. X is all by itself. So if we have x minus y plus 4z equals 10. Did I transcribe the equation correctly? Okay? And then we're gonna plug in the y and the z. So we have x minus y plus 4z equals 10. Subtracting a negative is the same as adding a positive, so we have x plus 2 plus, what's 4 times 0? Do I need to write that? Nope. Okay, and then what do I do to isolate x? Subtract 2. So we get x equals 8. So our solution is the ordered triple, 8, negative 2, 0. And that is our solution.